الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، السلام عليكم ورحمة الله وبركاته. اليوم سنتطرق إلى درس جديد في مادة الاستاتيكا، وطبعا احنا عارفين الاستاتيكا هي إحدى فروع المادة التطبيقية. Its title follow the center of gravity. My dear student, the previous lesson we know the center of gravity, how to determine the center of gravity by using the rule xg m1 x1 plus m2 x2 plus mn xn over summation of all mass. Also, we can determine the yg coordinates by using rule m1 y1 plus m2 y2 plus mn yn over summation of all mass. The center of gravity is the point, its coordinate xg yg. We know that the center of gravity is a fixed point, the line of the action between the center of gravity and the center of the earth, the line lie between them. And we know that, my dear student, the center of gravity is very important to calculate it in a rigid body as triangle, square or geometric shape. My dear students, today we are follow the center of gravity of a rigid body. Center of gravity of some simple rigid bodies. My dear student, number one, the center of gravity of uniform density rod lies at its midpoint. Remember, if we have uniform density rod, then we deduce that the center of gravity lies at its midpoint. Number two, the center of gravity of uniform density thin lamina in shape of a parallelogram or one of its special cases. What is the special cases of a parallelogram? Square, rectangle, rhombus lies at its geometric center. What you mean geometrical center? Point of intersection of its diagonal. Number three, the center of gravity of uniform density lamina in triangular shape lies at point of concurrent of medians. We know that point of concurrence divided each median as ratio 2 to 1 from the vertex or 1 to 2 from the base. The point of concurrent, it's a point which divides the median internally in ratio 1 to 2 from the base. Number four, the center of gravity of uniform density lamina in circular shape is the center of the circle. We know that the center of the circle is a fixed point which is equidistant from any point on the circle. Then we deduce that if we have a body, this body is uniform density or lamina in shape, circular shape. Then we deduce that the center of gravity is the center of the circle. Number five, the center of gravity of uniform density lamina in shape hexagon lies at the center of the hexagon. We know that the center of hexagon intersection point of its diagonal. Now we are translate to important example. A uniform fine lamina of mass 180 gram in the shape equilateral whose side length 6 centimeter. Wait, my dear student. Think before solve. We have lamina as shape equilateral triangle, each side 6 centimeter. The lamina, its mass 180 gram. This is called given. Body of mass 20 gram is fixed at point D, where D belongs to a C line segment and AD 2 centimeter. What is required? The center of gravity of the system. How to determine the center of gravity of system? Solution. Look at, my dear student, we have mass of lamina as shape equilateral triangle 180 gram. We replace the mass by 3 equal masses. Each of its 180 divided 3, 60 gram. My dear student, we replace the mass of lamina, which is 180 gram, by 3 equal masses, each of it 60 gram. Fix each at one of the vertices of triangle, then the equivalent system will be 4 masses placed, not 2 masses. Why? Because we divided the mass of lamina as 3 equal mass at A, B, C, and D, such as the point A, the origin point. Look at the figure to determine A, B, C, and D. This is lamina as shaped equilateral triangle ABC. The point D as a distance 2 centimeter from A. We know that the distance or the length of equilateral triangle is 6 centimeter. We replaced 180 gram, the mass of the lamina, into 3 mass equally, at A 60 gram, at B 60 gram, at C 60 gram. And don't forget, we have other mass 20 gram at point D. Then we determine the coordinate of each point. Point A 0, 0. Point D 2, 0. Point C 6, 0. Point D is 2 and the line which opposite angle A by using sine. Then form the table. At A, at B, at C, at D. Mass at A 60 gram, B 20, C 60 also, B 60, C 60, but D equals 20 grams. The X coordinates 0, 3, 6, 2. Y coordinates 0, 0, 3, 0, 0. By using the rule. What is the XG? 60 times 0 plus 60 times 3 plus 60 times 6 plus 20 times 2 over 60 plus 60 plus 60 plus 20 or 200. This rule to determine xg m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 over m1 plus m2 plus m3 plus m4. Then, my dear student, xg equals 2.9 centimeter. To calculate yg by using the same rule, yg m1 y1 plus m2 y2 plus m3 y3 plus m4 y4 over summation of m1 plus m2 plus m3 plus m4. Then the yg value 6 times 0 plus 60 times 3 root 3 plus 6 times 0 plus 20 times 0 over summation of all mass 200. The answer is 9 root 3 over 10 centimeter. This is coordinate of yg. Remember, my dear student, this is the center of gravity of the system. 9 root 3 over 10 centimeter. It's called the center of gravity respect to the point A. My dear student, the center of gravity of this system is equilateral triangle. If we have mass of lamina as equilateral triangle, we can divide it into three masses equally, M1, M2, M3 at three vertices A, B, and C. After that, we determine the coordinates of each point. Then we form the table to calculate the center of gravity. Center of gravity has two coordinates, x, g, y, g. xg equals what? m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 over summation of all masses. By the same method to determine yg. Then after that we determine the center of gravity of the system respect to the point. My dear student, look at another example. Now, my dear student, translate to important example. Uniform fine lamina of mass 180 gram in shaped equilateral triangle, side length 6 centimeter. A body of mass 20 gram fixed at point D, AD equal 2 centimeter. How to determine center of gravity of the system? We know that, my dear student, we put AX, AY to orthogonal direction. A is origin point. Now we can determine the center of gravity by divided the mass of lamina into three equal masses and determine the each point. After that, form the table to calculate the center of gravity, xg and yg. We know xg equals 2.9 and yg equals 10 root 3 over 10, the center of gravity respect to point A. We can solve this example by other solution. Instead of distributing the mass of triangle at its vertices, determine the center of gravity of triangle G as a point consonance of medians. G. What is the centroid? The centroid means x1 plus x2 plus x3 over 3, y1 plus y2 plus y3 over 3. This is centroid or point of coincidence. Point of coincidence, point of intersection of its median. We have 3 vertices A, B, and C. We calculate x1 plus x2 plus x3 over 3, y1 plus y2 plus y3 over 3 to determine the center or centroid 3 root 3. After that, look at, we have, my dear student, two masses, 180 at G, 50 at D. 50 at D, its coordinate D to 0. At G, this is a centroid, which we have it. My dear student, by the form table, form masses and their coordinate, we have 2 points only, or 2 masses represent at 2 points, at G, at D. G represent centroid. What do you mean centroid? The point intersection point of its median. Then the mass at G 180, mass at D equals 20 from given. X coordinate 3, 2, Y coordinate root 3, 0. By the simple rule, M1 x1 plus M2 x2 over M1 plus M2 to calculate the center of gravity, or xg and yg. xg 180 times 3 plus 20 times 2 over 180 plus 20 equals 2.9 centimeter. Yg, by the same rule, m1y1 plus m2y2 over m1 plus m2, answer is 9 root 3 over 10 centimeter. Then the center of gravity by the same method. Another example. Find lamina of uniform density in the form of triangle whose mass 80 grams. Two masses 10, 4 grams are fixed at two vertices A and B, and mass 8 grams is fixed at midpoint of AC. Prove that the center of gravity of the center coincides with the midpoint of median AD. This example can put it by other method. Choose the correct answer and give midpoint of AD and give 3 other points. How to determine the center of gravity is midpoint of median AD, or coincides the median midpoint of AD. Solution. First, replace of mass of triangular lamina, 3 equal mass, each one 6 grams, placed at its vertices, and also replace the mass 8 equal mass 8 divided 2, each one equal 4 grams. Look at, my dear student, at A, after we divided the two masses, then the mass, all masses at A, 10 plus 6 plus 4, 20 grams. At C, 4 plus 6, 10. We divided the mass of lamina of triangle ABC into 3 equal mass, each one equal 6. And we divided the mass at E is 8 into 2 equal mass, 4 and 4. Therefore, my dear student, we deduce that A and C, the mass at A becomes as shown. The two mass 10 gram placed at B and C are replaced by one mass 20 gram placed at D, where D midpoint BC. Therefore, look at the second figure. It presents mass at A 20 gram, mass at B 10, mass at D 20, mass at C 10, mass at N is 40 gram. Form table to calculate the center of gravity. Look at another example. Mass of magnitude 5, 4, 6, 3, 2, 7, 3 gram placed at consecutive vertices of regular hexagon. We know that, my dear student, regular hexagon has 3 sides, has 6 sides, equal in length, has 6 angles, each one equal to what? 120 degrees. And we know the center of gravity of regular hexagon, intersection point of diagonals. Remember, my dear student, we have 6 mass. We put at 6 vertices of regular hexagon. This proves the center of gravity of the system lies on geometrical center of the hexagon. Look at solution. We let hexagon A, B, C, D, E, F and choose the 2 orthogonal directional Gx, Gy, where G is the center of the hexagon. And we let the side length of hexagon is L. The mass are fixed at vertices A, B, C, D, E, and F, respectively. A is its coordinate L over 2, 3 root L over 2, B L 0, C L over 2, negative 3 L root L over 2, D negative L over 2, negative 3 root L over 2, E negative L 0, F negative L over 2, 3 root L over 2. Look at A, B, C, D, E, F. We determine the mass at A 5, mass at B 4, mass at C 6, mass at D 2, mass at E 7, mass at F 3. And we determine the center G, the origin point is G, represents 0, 0. Then we know that regular hexagon side length is L. After we determine the coordinate of each vertices of regular hexagon for the following table, at A, at B, C, D, E, F, vertices of regular hexagon. Mass at A 5, at B 4, at C 6, at D 2, at E 7, at F 3. What is the X coordinate at A? L over 2. At B L, at C L over 2, at D negative L over 2, at E negative L, at F negative L over 2. Y coordinate at A 3 root L over 2, 0 at B, negative 3 root L over 2. After negative 3 root L over 2 at D, 0 at E, negative 3 root L over 2 at F. By using XG to determine the center of gravity of system, M1 x1 plus M2 x2 plus 2 so on, then the center of gravity 0, x coordinates. By the same method, to calculate YG, M1 Y1 plus M2 Y2 plus M3 Y3 to M1 to M6 Y6 over M1 plus M2 plus M3 plus M4 plus M5 plus M6. Answer is 0. Then we deduce the center of gravity of the system lies as geometrical center of the regular hexagon. My dear student, by the end of the lesson, we know that center of gravity of some regular geometric shape is the center of its diagonals as regular hexagon. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.